Okay. Now, good to go, good to go, good to go. Please. Everybody should leave the line.
Alright. Yeah? Now, this is what we call the workstation itself. This unit is what we call the workstation. This unit, the red wire you see, each of them, like this one is almost 120 meters. Like so we are having closely about 480-500 meters on this, the whole of this. Now I've told you that we have there, what we have there is still electrode, and that one is the porous port, non-polarization port. The essence of having that one is to avoid what we call geophysical noise. If it's only resistivity we are running, we might use two still electrodes. There is even a system, kind of configuration that we can still use only one electrode and connect the two wires to it. It will send and receive the same electrode, still electrode. Do you understand? Now, as it's on, you are not supposed to touch the still electrode at any particular point in time. Do you understand? Because what it does now is, you know, initially you have your 4 electrode system. You know, you have your 2 normal C1, C2, P1. That's one you are used to, right? It's the same thing here. It's just that this is actually a bit more advanced and modernized. What this is doing now is that it's the same thing. This one, what it does is that C1, C2, you have P1, P2. You understand? The C1 and C2, they are sending, while the other P's are receiving. Now, what this thing does is that it changes from electrode 1, 2, 3, 4. The first 2 will transfer, will send signal. The other 2 will receive. It will make 3 and 4 send again. 5 and 6 will receive. It keeps switching. That is essence of this switcher. That's essence of the, that's what this thing does. This long one now. That's actually what does the work of human being in the whole system. So that's the costliest, one of the costliest item here, and very sensitive. You understand? Now, I didn't teach you how to, but when we are going to remove it, there are some cautions you need to take in plugging it in and actually removing them. Now, do we have any other this thing? Okay, this one is what we call this the rectifier. Now, because this uses DC current, now the generator gives you AC current, right? So the generator transfers. This actually is like your normal converter, just like in your solar system. You use a battery in the house because of the solar to convert it to AC. That's what this does. And this is capable of giving you a voltage of 1200 volts. Now, that will tell you what this does. This is like using your 1200 by 12. It's like using 1200 divided by 12 is like using 100. How many batteries? Like 100 batteries. This is like we are using 100 batteries. Kind of what you normally use. If you use small battery here, it will not work because the voltage it will see you just collect. It will be working, but you collect signal because you will not have. Now, what volt does? That's the difference between volt and current. The volt is the pressure. The current is just the amount of flow of charges. But the volt is the pressure. It's just like when you get water now, this, and if I fill this and tuck it under pressure, if I open it, what happens? It goes off. It means that this water can get to this man if it's under pressure. If it's not under pressure, it will only stop here. That's the answer. That's why actually what this will do most of the time, the volt is more dangerous. You understand? So it's the pressure. So it is that pressure. Now, when you are looking for doing what we call the IP, which is induced polarization, what we do here is it's just like sending current, and you induce the current. The earth itself acts as a capacitor. That when you know what they call induction. When you now induce it, it's not that it behaves. You want to know how much amount of charge it will retain per time and releases. Just like when you rub something that is, you have a magnet, you want to rub it on something and you want to make that magnetize it. You rub it and rub it, you bring your pen, you know what you do, you try to, and you see that you've actually induced that body to be magnetic also. So what we are doing is, we're sending the current, you understand? We're sending the current and we measure the time, how long the current, stays and discharges. This thing happens in a very minute second. You understand? That's actually what we call IP, induced polarization. And resistivity is actually your ability to conduct. You understand? In order to either is conducting or is resistive. Either the body is conducting or resistive. Now, that is actually what this measure. That is just normal principle. But if you look at this, what we are doing since is we are trying to say add water, do this, do that. We are trying to make sure that the ground, the surface, because in resistivity survey you have problems, and you must understand that. If you don't appreciate the challenges, you will know when you have problems, even when you are doing your data interpretation. Now, the problems, one thing is that the more you go down, the more your resolution reduces. The more you go down, your resolution reduces. That is, you cannot, in every geophysical, in short, in every geophysical survey, the more the depth, the more you go out from the real answer. You understand? That's one thing. Secondly, what helps in terms of conducting your current and having all this is the fluid, the water, whether the water and ions in the water, what it contains, whether it's salty, whether it has some elements like other solid minerals and all that. And again, how they are liberated. These are the things that actually determines how far your current can actually go. Not sometimes you might do the same profile, the same length. Here, you go to another geology, your current movement will be very fast, clear, and you get a cleaner data than in another place. It's all about the body in which you're actually transferring your, you're transferring your current and all that. So these are some of the things you need to understand. Now here, if you're talking about water, water is a very good conductor. You understand? Very good one, in the sense that once you meet clean water, if the water is contaminated, the resistors are different. Now, when the water is contaminated, what does it mean? It means that some elements or some metals are actually being dissolved in the water, and they help in conduct. The conductivity will be very high. So, if you look at it, your resistivity will be very, very low. Fresh water, most of the fresh waters are within 80, 90, 100, 200, 200, 250, 300 in terms of resistivity in ohm meter. You understand? You have to, by men looking at resistivity, you might start thinking about if you use SP, if you've done SP, you find out that when your SP goes closer, 10 closer to zero, if you are logging your well after drilling, if it's going closer to zero, you know that you're actually in a salt zone. In short, sometimes it will run between 0 and 1. You see it running straight. But then you now see a very sharp goes out of zero again, and that tells you when you've left clay formation, that's the way you see it. If you are in sand formation, that's the way it appears. If you are in shale, that's the way it appears. If you meet a fracture that contains water, that's the way it feels. If you meet a fracture that contains ore in the ground, all these things is a reflection of, but one thing is key. You must understand the geology of where you are laying anything. That's why most people make so much mistake. If you bring your geophysics without your geology, you must first of all understand what formation am I dealing with. What are the likely things that I'm going to see here? Because anything, resistive ranges are so much. Anything can give you any amount of resistance. There's no particular one. People will tell you, what will you see? You know that this is this. No. You must first of all have an idea of the geology. You understand? The idea of the geology will tell you where all these things are actually happening. Now, what we did before is when we set all the equipment, at least setting it up, you understood the process. Now, what we are doing now is we are using dipole array, and we are using about 48 electrodes on single electrode, and the other one together at about 96. Definitely we'll be looking at anything above 120 meter depth, 120, 130 or thereabout. For basics of the depth. Here we configure this in such a way that if we finish one wire, we are looking at something in the neighborhood of 30 meters. The way it's configured, you understand? And that is almost about 120. So divide 120 by 30, that will give you a percentage of your length. And if you read your physics very well, you can see that your depth of penetration, so many factors are involved. But you should have an idea that basic thing is that your depth of penetration is very much dependent on your lateral extent of of your wiring and whatever. You understand? So that's why you can't just, and the more you want to go down, the more you need to actually, spray and all that. So if you look at this now, why the essence of why you are putting the salt solution and all that is not because this is the surface actually, you want to reduce the surface resistance so that both of them will actually have a very good grounding. When you have a very good grounding, it means that it is actually in good contact with the ground. You understand? So that you have, because now the issue is when you don't have a good contact with the ground, naturally your resistivity will be high. You think that with the natural resistivity, but that is not it. We do know that because your contacts are not really good. That's why we are driving that electrode very much inside. So that the places we go, this electrode will not be this smaller one. You now have a electrode that will be up to more than this length, so that it can drop so much in the ground. You understand? And for the fact we are running both resistivity and IP at the same time, it becomes a bit more difficult, because if it's only two still electrodes, we'll just hit two, or we even hit one, and you do same one to collect and the same one to send and receive at the same time. But now we are running two things at the same time. So now what we've done now is that we've first of all configured, we've opened a project for this. We've configured this to have based on the length, based on the project, and based on the number of electrodes. Now if you look at this, come and see the screen. If you look at this, you can see BA, which is your C1 and C2, MN, which is your potentials. Okay, saving weight, yeah. 1 over, it saves automatically. I don't need to save it, it saves. And you can't impute something by yourself. That's one thing with it. You cannot impute, you cannot forge data. You can, if you delete, you cannot put it back. You understand? You can't say, hey, let me change this into 2 so my supervisor will look at it as in a line. You cannot change anything here. And once it's automatically, it's saving everything itself. Now you can see, now where it is now is 5 and 7. It means that 5 and 7 is sending, and 16 and 18 are receiving. Do you understand? You know, it switches. Do you understand? So that's it. So if you look at it now, if you go and touch the electrode 5 and 7 here, definitely you are going to fall. You get it? And it's when it's sending. You get it? But as it is, then I can touch here because it's not on 1. You understand? That's where it is now. I can touch here, it's not on. But for safety reasons, once it's working, you don't touch anything. You understand? The operator must know that that is it. Now you can see my volt in millivolts. This is volt, this is your current. You understand? And you see this is your SPV, and this is your chargeability here. You know? Now, this is actually how it goes. Depending on, I can do so many iterations here. You know? In short, there's the kind of work you want to do. We might study this place for 1 week. We'll set it up, give the guard. This thing you see can go up to, it can take up, I might do 200 electrodes at the same time. Can do 500 electrodes at the same time. We can set this thing, it can be monitoring. This you see can be set in a few things. And then I think you might ask questions so that I can now say some other things that I've not said. In terms of configuration, in terms of principles, process, other things. Yes. Yes.
Like you have chlorophyll.
Yes. No, it's about 1 is about 12.
You have chlorophyll.
That length from each of them. From this point to that point. I see. So it takes 12. About 124 thereabouts. Yeah.
She has chlorophyll.
So that's
she has chlorophyll.
So and the same thing, you can see we have this one. If one now, we can still join this one. You understand? The cable will still go. We'll have other ones now. We'll see. So it doesn't have. We keep joining depending on how you want to, extent you want to. But the more you join, the more your time, the more your money, the more it becomes so many things come to play.
From what you read, what kind of array are we using?
Yes, that could be.
What's the interval? Electric interval. Between
Spacing.
12. 12 meters. Oh, here they can
12 meters. Then
don't stop, don't touch it, don't destroy our distance.
you pick your. You can also make your videos or whatever you can. You understand. You understand. You understand.
Okay, GPS.
Yes.
Get GPS. You check what's the location.